Welcome everybody to the second part of this tutorial. In case you haven't seen it, in the last tutorial I explained to you a little bit how to use SQL Fiddle, and we created this table that you're seeing right here in the screen at the moment. One of the interesting things about this table is it contains 6 different rows. 2 of them are valid names, including my name in there. But if you check closely, there is row number 2 is just an empty string. Row number 3 is a null, which is database language for I don't know. Then rows 4 and 5 are strings with a certain number of spaces. And it's a bit difficult to count how many spaces exactly. So when you're faced to a data set that looks like this and you're asked to retrieve every row that is not valid. So in other words, anything that doesn't resemble a real name. The literal way, or the most precise way of doing it, would be to type where, then first name is null, or first name is equal to the empty string, or first name is equal to, and so on. And you just keep on defining OR clauses with all of the possible mistakes. Now, this is not a very clean solution, especially considering that we don't know how many spaces we're gonna come across, and the spaces will vary. So at this point I figured, okay, there has to be an easier way. My first try was with regular expressions. In case you don't know what they are, regular expressions is just a text search pattern like language. It is a whole thing on its own, and it's supported by a lot of programming languages and even databases and SQL dialects. In the case of T-SQL, it's very simple to use regular expressions. It's just really a matter of just typing them as a string, and it knows that it's a regular expression. So in here, I figured, okay, how about things that are not like a character from A to C in uppercase, a character from A to C in lowercase, or a number from 0 to 9 in lowercase. And I also added some wildcards, which is short for one or many, just in case there are leading spaces at the beginning or at the end. Let me run this. And now this returns every single row except the null row. So this already kind of works. But then there was something that I really didn't like too much, and that is I also tried, instead of typing the word not, I tried doing exactly the same but the regular expression equivalent. Now, if you're familiar with regular expressions, it makes intuitive sense that the caret at the beginning is a negation. So typing this caret should be exactly the same as the query that we just run, which is the not like. But when I run this, now I'm not getting row number 2. So it's like, uh-oh. I don't know why exactly I'm getting different tables when I change the like or not. And to be honest, I don't know enough to understand why this is not a correct solution. So, okay, I decided to go for something else. And at that point, I came across this formula called data length. So first name and then data length. I always write that word wrong. Now, what data length does is it tells you, it tells you in how many bytes a certain value is stored. And here's when things get interesting, that things like null has a data length of null, the empty space has a data length of 0, and then it just gives you different numbers. Maybe this is a really cool strategy if you want to know exactly how many spaces there are, but it doesn't really solve the problem that I had. Then I tried a different strategy, which is using SoundX. Now, in case you're not familiar, what SoundX is this algorithm. I'm not very sure how exactly it works, but what it does is it turns characters into a 4-digit representation that is supposed to be similar to the way that they are pronounced. So you see that this is the one for Juan, and funnily enough, the SoundX of all of my empty strings is 0, 0, 0, 0. Now, if you want to see a little bit how SoundX works a bit better, let me just show you like this. I think this is really gonna help you a bit better understand what it is. So we have two names, Juan and Joan, and a name that is completely different, like Carlos. When I run this query, I notice that Juan and Joan have exactly the same SoundX, but Carlos has a completely different one. So, okay, maybe I can use SoundX, but to be honest, I'm not comfortable enough to understand how this works to really just use it. What to me was the beginning of the solution was the formula length. Now, for those of you that are not familiar with this formula, what it does is it tells you how long a character, actually a value is. And in the case of Juan, it gives me 4 because there are 4 letters. Carlos gives me a 6. Null still gives me null. And interestingly enough, it doesn't matter how many spaces. The length gives you the word 0. For empty spaces and empty strings, they all have a length of 0. And this is the moment when I realized, like, got it. I know what's the solution now. The easiest way, maybe not the most readable to do it, is to use the formula null if, which if a certain condition is met, it turns it into a null. So I said null if the length of first name equals 0 is null. So once again, if you're wondering what exactly is this if null, what it does is it checks the length of first name. If it is 0, it casts the value into a null value. And if not, it just returns the first name. And now with this query, I was able to fetch all of the rows that have a value that is not valid or a value that I was not expecting. And this is ultimately the solution that we implemented. Now, I hope this was remotely useful. If there was any feature or any behavior of T-SQL that surprised you, I think this video was a success. So the golden rule of null values is if null is the input of something, the output is always going to be null. But there are ways in which we can handle some other problems like empty spaces and so on. And well, SQL is always an interesting thing. In case you're also wondering if this works in different dialects that are not T-SQL, kind of. In some dialects, length behaves very similar, but in not all of them. So you might want to test if this also works with your database. And I really hope you just learned something. To me, the SoundX was a new thing. Data length was also a new thing. So I hope you enjoyed this video and see you next time.